Hello friends, welcome back. In the previous video, I had posted a set of questions for you all to practice. Now let's see the answers to each question. On we go. The first question is, Dobby invests $1,000 today at 4% compounded annually. What will the investment be worth in 10 years? So the calculation is N is equal to 10. I/Y is 4 minus 1000 is your present value. Compute the future value. And the future value equals $1480.24. Now, the next question is, if Minerva invests $15,500 in her RRSP each year for 20 years at 6% compounded annually, how much will she have saved towards financing her retirement? Now, the first step is find out whether it's a regular annuity or annuity due. Since we do not have any terms here, such as investment starting today, we continue the calculations in the default end mode. So now we begin the calculations. 20 is your N, 6 is your I/Y, minus 15,500 is your PMT. Compute the future value. Yes, the future value is $570,176.66. The third question is, how much would Snape have to set aside today to finance 4 years of university for his child? Assume that the child will start the education in 5 years and that all the deposits will earn 5% compounded annually. Each year of university will cost $10,000. This involves 2 steps. First, let's understand this example. Now, let's assume it is 2025 and Snape's child would begin university education in 2030. That's 5 years from now. And he needs to pay $10,000 at the start of each year from 2030 up to 2033. First, we should calculate how much money should be present in his portfolio at the beginning of the year 2030 to cover the tuition cost for the next 4 years. That's step 1. So the step 1 is to find the present value needed by Jan 2030 in order to cover the 4 cash flows of $10,000 starting at the beginning of the period. This type is annuity due. Now, why is this a case of annuity due? Because the tuition fee needs to be paid at the beginning of each year. So immediately set your calculator to the BGN mode and calculate as follows. 4 is your N, 10,000 is your PMT. It's a positive number because it's a cash inflow. I/Y is 5. Find the present value PV. Now PV equals $37,232.48. Therefore, in the beginning of 2030, that's 5 years from now, Snape needs $37,232.48 in his portfolio, which will grow at 5% per year, so that he can withdraw $10,000 each year for the next 4 years to pay the university fee. Now let's jump into step 2. Find how much Snape should set aside today to have a savings of $37,232.48 in 2030. Now this is a very straightforward present value calculation. Now change your calculator back to the end mode and do the following calculation. 5 is N, 5 is I/Y, 37,232.48 is your future value. Now the present value will be $29,172.62. Therefore, if Snape invests a lump sum of $29,172.62 today at 5%, he will have $37,232.48 in 5 years. This amount will allow the child to withdraw $10,000 per year for 4 years, starting at the beginning of each school year. So after the last $10,000 is withdrawn to cover the final year's tuition fee, the balance of the investment portfolio will be 0. So now let's see the next question. A department store advertises that it charges 20% on overdue accounts, but the store compounds this amount daily. How much is the store actually charging? Here, you know the quoted annual rate, but you are required to find the effective annual rate. Just a quick review of what's a QAR and an EAR. The quoted annual rate, QAR, also known as the nominal rate, is the basic advertised rate, while the effective annual rate, EAR, is the true annual cost or the return, considering how often the interest is compounded. For example, the interest may be compounded daily, weekly, monthly, quarterly, and so on. Because compounding adds earned interest back to the principal. The EAR is higher than the QAR when the compounding happens more than annually. In simple terms, quoted annual rate is the basic annual rate without considering the compounding frequency, and the EAR is the actual annual rate of interest earned or paid after accounting for the effects of compounding. For example, a 10% QAR compounded monthly as an EAR of about 10.47%. because you earn interest on the interest each month. So now the question is, why do we have to use EAR at all? Because EAR gives the true cost, the true return amount, while QAR totally ignores the effects of compounding. You can use EAR to compare different financial products that have different compounding frequencies to find the best deal. Also, in the credit cards that we use, we can see that the EAR is much greater than the QAR because the quoted rate is combined with daily compounding. And when using the calculator, you always input the values in the F, R format, where F is the frequency of compounding and R is the interest rate. Type 365. Because the frequency of compounding is daily, therefore your F equals 365. Then press XY button. Now type the interest rate, which is 20. Type 20 now. Then press second F and then press EFF. Now 22.134 is displayed. So that's your answer. The final question is, your bank will lend Draco $40,000 at 10%, spread over a 4-year period, but compounded monthly. What will his monthly payments be? So do the calculations as follows. N is 4 times 12. Why? Because for each year, the interest is compounded monthly. Therefore, for 4 years, it is 4 times 12. I/Y is 10 divided by 12. Minus 40,000 is your present value. Now compute the PMT. PMT is $1014.50. Therefore, his monthly payments must be $1014.50.